All right, in this lesson, we're going to learn how to read the periodic table. So the periodic table is found in page 9 of your reference table. Page 9. Page 9 of your reference tables. And it should look just like this. So you're going to see, it may seem a little bit overwhelming, but each one of these boxes just represents a different element. There's 118 of them. And within each of those boxes, you're going to see some numbers. And so we're going to talk about what those numbers mean here. So on the periodic table, each box represents a different element. And then each element is defined by its number of protons. So for example, an atom with 1 proton, so we're going to go to find the number of protons, you look for the atomic number. So the atomic number is the number of protons. That's all it is. So for this example, carbon, it got the atomic number 6. That means we have 6 protons. So for the atomic number of 1, we're going to look way up here. Number 1, that's H, and H is also known as hydrogen. You can find the full names on page 10 and 11 in your reference tables. So 1 proton can only be H, which is hydrogen. An atom with 79 protons can only be, so we're going to go back up to our periodic table. 79 is right here. So that would be Au. And Au is gold. So again, looking at page 10 and 11 in your reference table, you'll see that element number 79, or atomic number 79, is called gold. So the periodic table is organized by increasing atomic number. And atomic number is also known as protons. So atomic number and protons are the same thing. Okay, now let's talk about what atomic mass means. So in each of those little boxes that represent each element, you'll see this top number is usually a decimal. That's the atomic mass. And so what atomic mass is, so atomic mass is the weighted average mass of all naturally occurring, and this is a new word, isotope of that element. So let's define isotope before we continue talking about atomic mass. An isotope, or isotopes, are atoms with the same number of protons. So that just means they're the same element, but with a different number of neutrons. So each atom or each element will always have the same number of protons. So every atom of carbon will always have 6 protons. Every atom of hydrogen always has 1, and so on. But they can have different numbers of neutrons. And so the atomic mass is kind of like the average of all of those isotopes that exist. So this would be like an example. Carbon normally has a mass of 12, and that's because it has 6 protons and 6 neutrons. But sometimes you can have a carbon that has a mass of 14, and because it's carbon, it has to have 6 protons. But in carbon 14, it would actually have 8 neutrons. And so each of these numbers coming after the carbon, that just represents the mass number. So the mass number is like the mass of an individual atom. And then the atomic mass is like the average of all of those mass numbers. So let's define mass number. Mass number is number of protons plus number of neutrons in an atom. So mass number is for an individual atom. Atomic mass is for all of the atoms of that element. So that's the average, essentially. Okay, next we're going to talk about electron configurations. So in each box on the periodic table representing each element, you're going to see a series of numbers separated by dashes at the bottom left-hand corner of the box. So if we zoom in on carbon here, you're going to see this is the electron configuration. And for carbon, it's 2-4. So what that 2-4 means, electron configurations show the number of electrons found in each orbital / shell. So for carbon, we have 2-4. So this 2 just means that you have 2 electrons in the first orbital. And then the 4 means that you have 4 electrons in the second orbital. So if we were going to draw this atom, this would be our nucleus. And the number of numbers in the sequence tells you the number of shells or orbitals. So that's why I drew 2 rings or 2 shells around the nucleus. So the first one would have 2 electrons, and then the second one would have 4 electrons. And remember that outermost shell, that's also called the valence shell. And then the total number of electrons here is equal to the total number of electrons in that atom. So for carbon, it would be 6. Okay, so looking back at the periodic table, you're going to see that there are, it's organized into rows and columns. There's special names for those. So let's name those. So the rows are actually called periods. There are 7 of them. You're going to see these 2 rows down here. Those are actually part of rows 6 and 7. So they're just included in those rows. They just don't fit. So we write them down at the bottom, but there are 7 rows. And then you're going to see that there are 18 columns going across from left to right. So columns, and these are actually called groups or families. There's 18 of them. Now these are very important to know. So if two atoms are in the same group, or two elements are in the same group, let's say elements in the same group have similar properties. So that is very important to remember. So for example, if we look at the first group right here, something like lithium and sodium, again, you can find those names, the full names on page 10, so the next page in your reference table. Because they're in the same group, they're going to have very similar chemical properties. We'll talk about why that is later on. There's a few categories of elements that we need to know. Categories of elements. So the first one is going to be metals. Let's just list a few traits. So metals are left of the bold staircase. So what that means is if we look above here, you're going to see, and I'll highlight it, there's that bold staircase on the periodic table. So anything left of that would be a metal. So left of the bold staircase. Periodic table. Metals will typically lose electrons, and if they are losing electrons, or they're losing something that is negative, this means that they will typically form positively charged ions, which we talked about in a previous lesson. So if they form positively charged ions, these, the more scientific name for positively charged ions would be called cations. Metals are also good conductors. Of heat and electricity. They are malleable, which just means they can be flattened into thin sheets, and they are shiny. And this is also known as luster. The next category would be nonmetals. So this was metals. Now we'll do nonmetals. So nonmetals are to the right of the bold staircase. Nonmetals typically gain electrons, and if they're gaining electrons, this means that they will usually form negatively charged ions. So if you're gaining an electron, you become more negative, so you form a negatively charged ions. And negatively charged ions are known as anions. Nonmetals are also poor conductors. They are brittle and are dull in color. Now, the last category would be something like metalloids. These are also known as semimetals. And these are on the staircase. And so these would be B, Si, Ge, As, Sb, Te, and Po. You can find the full names of those on page 10 in the reference table, but these are all the elements that are known as metalloids or semimetals. And what's unique about these is that they possess properties of both metals and nonmetals. The last category would be the noble gases. So these are all found in group 18, or that's the 18th column. Noble gases are extremely stable, and so this just means that they they're typically not involved in chemical reactions. So because they're so stable, they don't really react with anything. That's kind of all you have to know right now about noble gases. The last thing I want to cover is just special group names. So these are just names of individual groups. Group 1, or the first group, and this is not including hydrogen. So I'm just going to go back up to our periodic table. So you'll see within this first group here, hydrogen's kind of separated. That's because it's not really included in group 1. So the first group is known as the alkali metals. Group 2 is known as the alkaline earth metals. Groups 3 through 11 are known as transition metals. Group 17, these are known as the halogens. And then lastly, group 18 would be those noble gases.